Welcome everyone to our second mechanical tools workshop, intermediate level this time. Unfortunately, my past presentation partner has not been able to join me today, although ironically, we've doubled the number of tools that we're talking about today. So it's just going to be me talking a lot about a lot of different tools, common hand tools that we use on the FRC teams when we're building robots. So let's just dive right into it. So I'll start by listing some of the common tools that we use in our workshops. Most of these tools are really easy to use, although they take some getting used to. So the more you use them, the more you'll improve. It's just practice makes perfect. So today we'll talk about hammers, two different types of saws. Only the bottom one is a hand saw, but they're both saws. Files and squares. We'll also be talking about some common tools that we use a lot just for FRC purposes. So a deburring tool, caliper, auto punches, and center punches, which are basically the same thing, but one is automatic. A scribe tool, a rivet gun, wire strippers, and a socket set. So let's start off with our first tool, which is a hammer. Hammers are used, of course, for fastening two pieces of wood together. It's usually wood. The way we use it, you want to hold it like you're giving the hammer a handshake, usually near the middle of the hammer. If you need more control, you can hold it near the head, and if you want more power, just hold it near the end of the handle. When we first start hammering, we want to, of course, put the nail where we want to drive it into the wood. You want to avoid hammering a nail into the grain, though, those lines in the wood. And this is to just avoid splitting the wood as you're hammering it. So you hold the nail with your thumb and your forefinger, and you want to hold it near the head of the nail. And the reason for this is because if you happen to miss your swing, you might end up crushing your fingers between the wood and your hammer, and obviously that's going to hurt. So to avoid that, we hold the nail near the top so that if we do miss, we just, our hands aren't in danger, basically. And make sure that when you're hitting the nail, you hit it on the head. So at a smooth 90 degrees, as you can see in this picture. So you want your handle to be perpendicular to the nail, just so that you get like a nice strike head on. Make sure that when you first start hammering, you just start tapping the nail. You might want to hold it closer to the head for more control, and we just tap the nail a bit until it's driven deep enough into the wood that it can stand on its own, and then after that you can use more power. And to get a direct hit each time, here's a tip: look at your target. So focus on the nail, not the hammer. In fact, you don't even want to be exerting every ounce of your strength for each swing, because that will lead to messy swings, and eventually you'll end up bending your nail because you're not hitting it at 90 degrees each time. So another tip: let the weight of the hammer do most of the work. You don't have to focus on putting a lot of effort into each swing, just let the weight do the work, and you just need to focus on hitting the nail straight at the 90 degrees. I can't stress enough, go at 90 degrees. More inexperienced hammerers maybe don't focus on this enough, and they'll end up hitting it at like slightly over 90 degrees, and then they end up with a crooked nail, and then you'll have to start over. And no one wants to do that, so let's learn from their mistakes and make sure to get that 90 degrees. For maximum power, you can swing from the elbow, and for more finesse and control, swing from the wrist. So since at the beginning we're just trying to tap the nail into the wood, you might want to start off with hammering from the wrist for control, and then once it's deep enough in there, you can go for the power with your elbow swings. Another feature of claw hammers specifically is that the little claws on the hammer are designed to remove nails as well. So to use those claws, you basically just slip them underneath the nail's head and then pull the hammer handle towards you, so against the wood surface for leverage. And then that should pull the nail out of the wood. And for really long nails, you can also, here's a trick, you can put a block of wood underneath the hammer's head for more leverage. And then that way you're putting less strain on the hammer's handle, and you're also preventing your nail from coming out on an angle all bent. So the next tool we're going to talk about, well, two tools actually, but they're both saws. We're going to talk about saws. Saws are used for cutting pieces of wood, plastic, or metal, whatever material it is. All saws cut using their jagged, sharp teeth, and they cut softer materials. And different types of hand saws made with different materials and designs are used for cutting these different types of materials that I just listed. The two main types of saws that we use on FRC teams are the hand saw. So they're characterized with a large, heavy blade and a single handle, and they're used for cutting wood. And then the second type of saw we use is called a hacksaw. And you can see that they have a fairly long and thin, brittle steel blade that we hold. We hold the saw with at 2 points, so in this handle and then up here at the front. And hacksaws are used for cutting metal. Manually sawing might actually be necessary in some case or more convenient than when you're using power saws. One good example of this is when you're cutting a round cylindrical piece like in the picture here. And it's necessary to manually cut these round pieces because otherwise we would be putting the whole weight of a bandsaw on it when we're cutting. If you've ever seen a bandsaw and how it's used, you're putting a lot of weight on the cylinder, and that might actually end up warping its circular shape. So for avoiding this, we usually just clamp the cylinder in a circular clamp, and then we just manually saw it to avoid warping its shape. So how to actually use a saw? Before sawing, you want to first secure your workpiece to the table so it doesn't shift around. In fact, when you're actually sawing, there's a lot of friction between the surface of your workpiece and the saw blade, so much so that if you're not securing it tightly to your table, you might actually just end up dragging the workpiece around as you're sawing. So make sure it's secured nice and tightly, and make sure you secure it at a comfortable height. Usually at hip level is good. And as I said before, we have two different types of saw that cut different materials, and they're also held differently. So for a hand saw, you want to hold it with your thumb and 3 fingers in the D-ring. So the D-ring is basically just that little hole in the handle. We call that a D-ring. And then you can also get your index finger or your pointer finger to point down the side of the blade for more guidance or control. Make sure that you always keep your wrist, arm, and shoulder aligned with the blade, so they should all just be along one straight line. And also make sure that you keep your elbow close to your body so that prevents the saw blade from tilting to side as you're cutting. And it also helps to put the foot opposite to the hand that you're using to saw, which is usually your dominant hand. So if you're sawing with your right hand, you might want to put your left leg forward just for stability while you're sawing. For a hacksaw, you basically just want to hold it with both hands fully clenched. No need for like the whole finger business, whole index finger business. But you want to make sure that you do keep your dominant hand, which will be in the D-ring here. In the D-ring, just keep it in there. And your non-dominant hand, which will be on the other side, make sure you keep your hand on the outside or on the front of the handle. The reason you want to make sure you do this is because in the case that you ever slip, your hands slip, you would be putting them less in danger of falling into the saw blades if you slip. Same thing goes for the handsaw. Make sure that you keep your hand in the D-ring and not somewhere else. It's for safety's sakes that we hold it the way we do. When you're sawing, you want to saw at about a 45-degree angle to the surface for most efficiency. For steeper angles, you might end up using that steeper angle for making more aggressive cuts. And for a lower angle, that we use those lower angles for fine cutting. Oh, and a tip, when you're cutting, you want to not cut directly on the marked line. This is because when you're actually cutting, you're shaving off some of the material and it comes off as like the dust, right? So you're losing a bit of material if you're just if you're cutting directly on the marked line. So what we do instead is we cut a little bit on the side of the marked line on the waist side. And so if we do end up cutting, at least if we do end up cutting, we can't add length if it's too short, but we can shave off the piece a little bit if we end up cutting it out slightly too long. So for those reasons, that's why we cut a little bit off the side and not directly on the marked line. But when you start cutting, you want to start with a few backstrokes to make a little indent in the wood or the metal to basically guide your saw. So the way we do backstrokes is we position the blade with the portion nearer to the handle with the D-ring on it. We put that onto the workpiece, and then we make a short motion to cut a small notch or groove in the material. For hand saws, you can use your other thumb that's not really doing anything to stabilize the blade when you're positioning it on the cut line. And then to do another back cut, you just lift the saw up, reposition it with the portion of the blade closer to the handle on the workpiece, and then just make another short cut lightly. You don't need to put too much force. And then that should deepen the little notch that you've already created. After a few of these back cuts, you'll start moving your blade back and forth along the cut line using long and easy strokes, making sure that you let all the teeth get their turn to cut. And you want to let the saw do most of the work, like the hammer. You don't want to be gripping it too tightly or exerting too much force. You want to just kind of go with the motion that the saw blade wants to go into. Though, fun fact, most saw blades actually only cut in one direction. So if you see in the image at the bottom, the teeth are only sharpened in one direction, that is the forward direction. So when you're actually cutting, you want to put more force into the forward stroke and relax on the back stroke. Back strokes are more like a resetting stroke. It's also important because hacksaw blades are immovable, that you check that the blade is put in with the right way, with the sharp ends of the teeth facing forward, or else you'll end up decreasing your cutting speed. And when you first buy a new hacksaw, actually, it's very helpful that they add an arrow near the top of the blade to tell you which direction is the right direction for new hacksaws. If you veer off course while sawing accidentally, you can just stop and reposition the blade and then continue cutting. And as you near the end of your cut, you can tell this because the pitch or the sound that the sawing makes is going to change a little bit. You want to start shortening your strokes and steepening the angle to get a fine finish, because at this point the piece is barely hanging on, so you want it to just come off nice and clean. But also note that you're making shorter strokes, but you're also doing it more lightly, because at some point when you least expect it, the piece is just going to drop off, and you don't want to be going full force when mid-stroke. You no longer have any of the piece's surface friction to slow you down, and then you end up slamming your knuckles into a wall or table and maybe even tearing off a layer of skin. So ouch. Just make sure that you're going a little bit more lightly, because at some point it will drop. Oh, and also for metal, funny thing is that it actually heats up when you cut it. So just a warning that the ends where you just freshly cut it, they might be a little bit hot. So just be careful when you're picking up a piece that you realize it might be hot. And for safety purposes, always wear goggles to prevent sawdust or whatever other particulates are coming off from getting in your eyes. Once I had to saw a 3D printed part, and I remember I either didn't wear safety goggles or I didn't wear big enough ones, because some of the dust particulates, the plastic particles, it got into my eye, and I can't tell you how uncomfortable it is to have these weird red particles in your eyes as you're blinking. It's an uncomfortable feeling, so spare yourself that kind of suffering and just make sure to wear safety goggles. Manually cutting is just a bit awkward at the beginning, but the more you do it, the more you'll get the hang of it. So now we're going to talk about some tools that we use in what we call finishing touches. These are the tools that we use to kind of get rid of those small imperfections that we have in a material after we're done machining it or welding it or whatever we did to the piece. So the first finishing touch tool that we're going to talk about is files. Files are used to remove fine amounts of material from a workpiece, either on their faces or edges. Like saws, files cut material using their teeth. They are made of usually heat-treated high-carbon steel, which is harder than most of the materials that you'll encounter, so that when the file is rubbed against this softer material, the teeth will dig into the material and pull small bits away, like particles of metal or wood or plastic or whatever it is that you're filing away. So basically it's like a nail file, but for metal or wood or plastic. Types of files come in different types. They come in different shapes and sizes and surface textures. For the shape aspect, you can see here that we have 3 different shapes of files. That first one, a flat file, is used for either shaving down those rectangular flat sides or for smoothing out edges. This semicircle shaped file can be used for filing the more curvy or rounded edges or faces of things. And then this like completely round file, we use that for filing the insides of holes. A thing to consider is surface textures can come with two different characteristics. The first thing you can consider about the surface texture of your file is the size and spacing of teeth, and this corresponds to coarseness, or in other words, how much material is removed per stroke. Coarse files have large teeth with teeth spaced out more, and they're usually used to shave down material really quickly, like if you cut a piece too long, you use a coarse file to shave it down. And fine files have small teeth, but they have a lot of teeth and they're spaced together. And those are used for smooth finishes. So let's say you cut a piece of metal and you just want to smooth out the rougher edges so you don't get scratched or even cut on them, you would use a finer file. And then the second aspect of surface texture is the actual cut or pattern of a file, which will affect its filing speed and its efficiency on different materials. So here I have 4 different patterns for a file. The first one, a single cut file, is good for both soft and hard materials. The second one, the double cut, it has this extra set of diagonal teeth, which allows it to cut twice as fast. These double cut files are good for hard materials, but they'll clog up if you use them on softer ones. This third type is a curved cut, and with its curved contour, it's used for smoothing and blending different textures together. And then finally, this weird one called a rasp cut, and it has these tall separated teeth that are used to remove a large amount of material from softer materials like wood or plastic, but they'll get really dull if you use them on hard materials. And also note that certain files might actually have different surface textures on each side, so beware that if you have one side that's a single cut, maybe the other side is a double cut, so just catch on to that. So how to actually use files. The way you hold a file is you usually want to hold the handle of it with your dominant hand, and you use your dominant hand to guide the file's motion. But you can also hold the other end of it with your other hand to provide more control, assuming that you have the workpiece secured to a table or something. With heavy filing, you can use your other hand to press down on the end with your palm, and that removes more material more quickly, though pressing too hard will also dull the files. So in some cases, it might just be better to just switch to a coarser file. And with light filing, you can hold the other end down with your thumb for light removal of material or surface finishing. And you can even alter the pressure that you exert with your thumb to regulate the amount of material that you want to remove with each stroke as well. If you ever see anyone that's just moving the file back and forth, stop them. This way of using a file is both inefficient and potentially damaging to the file. The correct technique is to push on the file when on the forward stroke, and then lift the file off of the surface, draw it back, and then do another forward stroke. This is because files only cut in one direction, forward, and so files like saws have an angle relative to the work surface that we call a rake. And so you can see in this image that it's when you're pushing on a forward stroke, these teeth kind of dig into the surface of the workpiece. But if we were to go in the other direction, the rake is much shallower, so they're not actually really digging into the surface, and instead they're actually probably pushing off of the surface. And this damages the file because you're rounding the tips of the teeth and making it dull without actually doing any work. And the second reason you don't want to just go back and forth is because it also clogs up the file. Because as you're cutting material off, it kind of collects in between each of these teeth, and that will make the file less efficient. So even with a single pass, the little dust will kind of build up between the teeth. And when we lift the file off of the material after a forward stroke, we kind of let some of the material in between the teeth fall out, and that makes room for the next pass. When filing a face, so a surface, you want to make sure that the file is flush to the surface, of course, but if you're filing down an edge, you can start filing at like a smaller angle, like 25 or 30 degrees, and then gradually increase that angle to get a smooth, rounded finish on the edge. And then the last thing you want to remember is that before, but especially after filing, you want to use a file brush to clear the material out of the file. Get all that dust and debris out so that you're making the file more efficient when you're using it. And also remember that finer files need to be cleaned more often than other ones. So this is just good file hygiene. The second finishing touch tool that we'll talk about is a deburring tool. So deburring tools are used to remove burrs. Burrs are basically these rough edges or ridges that are left on a metal piece after we're done machining it or welding it. And then we remove these burrs to create a smooth and reliable part. These burrs can be really annoying because they can snag on clothing, they can poke fingers, and also more annoyingly, they will prevent parts from fitting together. Because let's say you designed a part to perfectly fit into another piece, but then you have a burr on the end. That burr might prevent the piece from fitting perfectly flush with the other one, and so that will prevent the parts from actually being put together. And also burrs are ugly, so all the more reason to remove them. So this is what a deburring tool looks like, and it can be used in two ways. So it can be used to scrape the insides of holes, or they can be used to kind of scrape the sides of these flat pieces. And the way you use the deburring tool is you kind of just scrape it along the edge that you're trying to deburr. You almost use it like a knife. You don't have to apply too much pressure, just enough to kind of remove the burr. And I might also add that the hook on the deburring tool can also rotate around to meet the piece at the perfect angle, or to meet the edge at the perfect angle to remove the burr. However, you can also use coarser files to remove burrs, but these tools are more fun to use, and they're probably also more effective in most cases. The second type of a deburring tool that I want to talk about, because we got more than one deburring tool, is this countersink deburring tool. And we use these only to deburr the edges of freshly drilled holes. You basically just stick it into the hole and then you twist it around, and that will remove the burrs. It doesn't even require a lot of force to use, just enough to get rid of the burr. And then of course you can run your deburred piece through a file to get a nice, like a fine file, to get a nice smooth finish. And just to stress the importance of removing the burrs, so I have this picture here with all those different degrees of severity of burrs. And you can see in this last row, imagine you have to put a screw into it. It might not even fit just because those burrs are preventing it from fitting, even if you have the right size screw. Hence the importance of deburring. We want our parts to fit together, and we want them to look gorgeous while doing so. So the next set of tools that I've kind of categorized together are these measuring tools, which will help you measure certain things like angles or dimensions. The first tool I'll talk about is called a combination square. So there are many different types of squares that you've probably heard of, but the ones that we use the most often in FRC are combination squares. So squares that have this like normal ruler and then what we call a stock, which is that plastic portion. And they're used to mark lines on a piece at angles of 45 degrees, 90 degrees, or 135 degrees. So you can see in the picture here, we have 90 degrees, 135, and 45 degrees to an edge or side of a workpiece. And so the way we do this is we will hold the stock of the square against any edge of the workpiece, making sure that the blade is flat against the surface. Then we position the stock, you want to hold your stock with your less dominant hand, because then you can use your dominant hand to draw the line. You start from the stock and then you just draw the line along the edge of the ruler. So positioning the stock on its different sides will result in different angles. So you see here in the picture again, by putting the stock with this straight 90-degree side onto the side of the workpiece, you get 90-degree angles by drawing a line on the edge of the ruler. But if you use the other side, you can get 45 degrees, or the other side of it, 135 degrees. But regardless of how you position the stock against the edge of the workpiece, just remember that you're always drawing a line along the edge of the ruler. And also, You can adjust the position of the ruler by untwisting that little adjustable knob, so that little golden piece there, and then you can shift the ruler a little bit and then re-tighten it. And you want to make sure that you don't loosen the knob too much or else the ruler will actually fall out. And personally, in my experience, it's a pain to put them back, so just warning you. Our next tool that we're going to talk about is a caliper. So calipers are measuring devices that are used to precisely measure the dimensions of an object. They can be very useful for measuring round objects, especially because I'm not sure if you've ever tried to measure the diameter of a circular object, but it's very difficult because you can't really be sure with your naked eye that you're measuring the 2 points on the circle that exactly correspond to the diameter and that you're not over or under measuring from a certain point. But when you use a caliper, it has those two jaws, which are essentially like two parallel lines that just like squeeze on the sides of that circle, and then you can get a perfect measurement of its diameter. So no more hassling with whether or not you have the right dimension. Calipers have two sets of jaws. The upper set of jaws are used for measuring inside dimensions, which are basically the distance between two inner surfaces, like the distance of a hole. And then the lower set of jaws are used for measuring outside dimensions, which are the distance between two outer surfaces. And you probably know what I mean, even if you don't really understand what I mean by inner dimensions and outer dimensions. Just whichever jaw will work to measure the distance that you're trying to measure. Just use those ones. So how to actually use a caliper? You hold the caliper with your 4 fingers, and then you use along the ruler, and then you use your thumb to kind of adjust the distance between the jaws. And there's usually like this grippy texture on a caliper, and that's where you want to put your thumb to adjust the distance between these two jaws. And then as you're measuring something, you want to get the jaws as close to the distance that you are measuring before gently sliding the jaws close to touch the surfaces. And you just want them to be close because it's less work for you. If you're holding a piece with one hand and trying to adjust the jaws at the same time, you just want them to be close so you don't have to just keep adjusting or keep sliding the caliper or the jaws together with your thumb. But also you just want them to be close so that when you do shut the jaws together, you're not like slamming them into the piece. You don't have to apply too much pressure on the sides of the piece to make sure you're getting a precise measurement. It's not necessary, and also you don't want to damage the piece by leaving marks or crushing it or something. You just want it to be tight enough that the piece isn't able to just shift around if you're not holding it. Calipers are measured in both imperial and or metric units, which you can see based off whatever units are on the ruler. Some calipers even have a button to switch between the two units for imperial, or between the two units. That's if they are a digital caliper, because there's also things called analog calipers, which use kind of like a weird scale you have when you're weighing your fruits or vegetables in the grocery market, that kind of scale. But for those digital calipers, you have a button that you can switch between the two units, so that's helpful. For imperial, they measure in thou, which is a unit that is equivalent to 1,000th of an inch. And in metric, they use millimeters. Also, you want to make sure to zero the caliper and calibrate it correctly. So basically, you put the two jaws together and then press the 0 button. Oh, this is for digital calipers, of course. And then that will basically recalibrate it. And you want to make sure that you recalibrate frequently enough because sometimes the battery is running out and it just gets miscalibrated with time. I like to recalibrate it each time I pick it up, both for accuracy and also because I like pressing buttons. So I've covered the basics for calipers, but for a much deeper dive, you can also look at Bruce's workshop called Calipers and Other Measuring Tools, where he explores uses of calipers that you probably didn't even know were possible. So check out his workshop as well for more information on calipers. All right, so now we're going to talk about tools that we use specifically for marking where we want to cut or drill on a piece. So the first thing we're going to talk about is scribes here. Scribes are used to inscribe a thin line on typically a metal workpiece, and That's to mark where you want to cut a piece. And the way we use it, you hold the scribe basically like a pen at about 45 degrees to the surface of the workpiece. Place it against the bottom edge of the ruler, engineer square, or whatever template you're using to mark along, just like in the image here. And then keep the tip up against the edge at the same 45-degree angle, and then drag that scribe in a smooth line in the direction that the head is tilted. So in most cases that's towards you, but you want to go in the direction that the scribe is tilted. And make sure to apply enough pressure the whole time. Remember that you want to have constant contact with the workpiece to produce a neat, thin line that will be bright enough to stand out from the dark ink surface of metal. And try to do it all in one stroke to create one smooth, continuous line marking. If you go with multiple strokes, then you might end up with actually two lines, and then it'll be confusing on which one you were actually trying to cut on. And here's just a picture of an example of where you're trying to cut, and you're cutting along the scribe line, basically. But that's all there really is to the scribe. It's kind of just like a pencil for metal. The other tool that we use to mark our work is called center punches. So center punches are used to create a shallow indentation in a material to mark where a drill will enter the workpiece. It's just kind of like a bump, like hole in the workpiece. It's not a hole, but like in this image, that little dot there. So we use these center punches to make these indentations because that helps guide the drill as to where it's supposed to drill and prevents it from wandering off course as it digs into the workpiece. This is especially bad for metal if you don't use a center punch, because the second that drill piece hits the surface of a metal, it might even just slide a bit because, metal's a little bit smooth. But if we make sure to use a center punch to mark a little hole where the drill can enter the workpiece, that just keeps it from veering off course and it just drills in the right spot. So the way you use a center punch is you want to hold the center punch straight up, perpendicular to the surface with the sharp tip on the surface, of course. You want to hold it with your non-dominant hand so that you can use with your dominant hand a hammer to give it a single good strike. One strike is all it needs. And remember, let the hammer do the work. And then that will just create a small indent that you can use to guide your drill. Center punches come in a variety of different sizes, as you can see here, and that's just to correspond to the different size drill bits that you use. So there's a center punch for every drill bit. And then another type of punch, basically the same thing, but it's automatic center punches. Like I said, they're basically the same thing as a center punch, but instead of using a hammer, you use a spring mechanism to drive the point into the workpiece. Here's kind of like a diagram of what's going on inside of an automatic center punch. So above the red part, there'll be a spring, and then when you press down on the center punch, it basically pushes this whole thing upwards into the loaded position. And then once that blue tip kind of slips into the red, the spring is going to push down on the whole system here, and that's going to drive the point into the workpiece and make a little hole. Another cool feature of automatic center punches is that you can also adjust the strength of the impact. At the end, you can screw out the end of the automatic center punch to lessen the impact, or you can screw it in to strengthen it. All right, so now we're going to talk about a tool that you probably haven't even heard about, and that is a rivet gun, and also rivets. We're going to talk about rivets as well. So pop rivets and rivet guns. Pop rivets are basically mechanical fasteners that are used when there is limited or no access to the rear side of the parts being joined. So in this image here, we have these two parts being joined. The rear end is basically just the end that is not exposed to the outside. So this is the rear end. And pop rivets are ideal for supporting shear and tensile loads. So here we have these two rivets. I like to think of them as little top hats on sticks, just to remember what they look like. And in this diagram, you can see just what a pop rivet looks like. We have what is called the actual rivet here, the body, and then the mandrel, which is like the stick. And there's also a flange, or the rim of the hat. That will also be important. So how do we actually use rivets? So you start off with actually drilling the hole. Then you'll load a pop rivet into the rivet gun with the mandrel first, like here. And make sure that the mandrel of the rivet is completely inside the rivet gun, like here. Gun to nose to flange to the work surface, basically. And then put the pop rivet insert the rivet's body into the drilled hole, its entire body, like in this image here. So just the flange should be touching the surface of the material. Then for power riveters, all you have to do is just squeeze the trigger, but for manual riveters, you have to apply pressure to these two levers and then do that until you hear a snap. And that snap will basically indicate that this mandrel has been snapped off, better in this image, it's been snapped off of the rivet, and now the flange is the only thing that forms the rivet's head. And then here we because this mandrel was pulled out, this little rivet here was pulled into the body of the top hat, and that has created this little bulge here that basically stops the rivet from going this way, and then the flange here stops it from going that way, so now it's basically stuck here. And that's why also it's such an effective fastener, like compared to bolts and nuts, where with enough vibration they can even untwist, enough vibration and time they can untwist. This system is pretty much never going to break down, unless of course this the bottom part, the bulge, ever gets damaged, and that's also why we want to protect the rear end. So we want limited access to the rear end, protect that little bulge there. Otherwise, rivets are very effective, and you can probably see why they're effective against shear and tensile loads as well. Trying to like shake these two pieces probably wouldn't work. So other important notes that you want to remember is that when selecting rivets, you want to make sure you have the right sized rivet for the right sized hole, or in other words, you want to make sure that the size or diameter, is how they measure the size of rivets, is matching the size and diameter of the drill bit that actually made the hole. Another important thing to note when you're selecting your rivet is the actual length of the mandrel. You want to make sure that the mandrel isn't too short, because if it's too short, the head might not even fully form, and then you won't have a very large bulb at this end, and that will just make a very weak joint. On the other hand, if your mandrel is too long, for your purposes, the mandrel will probably break above the surface, and then you'll have to you'll be left with like this stub in the middle of your piece, so you'll probably have to just shave it down, and that's annoying. So picking the right length of mandrel is important. FRC teams use aluminum rivets, which are the least strong, but other rivets may even have a steel mandrel or just be entirely made of steel, and that makes them stronger. And some rivets are even designed to be waterproof and have a seal to protect them, because you see here in the middle of this rivet, there's going to be this hole, right? And to make them waterproof, some rivets are designed with a seal to protect them. My point here is basically there's many different types of rivets, so you have a lot of choices when it comes to rivets. All right, so let's talk about wire strippers now. You probably heard of wire strippers before, but maybe you don't know how to use them. Wire strippers are used to remove the protective casing or insulation off of wires before we use them to make electrical connections. So each hole on the wire strippers, you can see these different holes, corresponds to a different wire gauge size. And we also have things called combination wire strippers, which in addition to being able to strip wires, also include plier jaws, cable cutting blades, and threaded holes for bolt cutting. The way you use those are basically you just screw the bolt into the right size threaded hole and you clamp down to cut it. So it's like a one tool for many purposes. So the way we actually use wire strippers is that we just open the wire stripper handles, and then we seat the wire on one of these sides in the appropriate hole size. And it's very important that you actually know the wire gauge, or basically the diameter of your wire, because if you put it in a hole that is too big, you probably won't even be able to cut through the insulation all the way. And if you use a hole that is too small, you'll cut through the wire too and damage it. So make sure you know the size of your wire and put it in the right hole. Then, once you have your wire in the right hole, you're going to gently press the handles together until they can't go any further. And if the insulation hasn't broken off at this point, hasn't been cut through at this point, you can also just give it a little twist You don't have to twist too much, just like a quarter turn in each direction, and that should be able to cut through the insulation entirely. And then finally, you get to just pull the wire strippers away from the wire towards the cut end, so in this direction, to remove the insulation. This might be a little bit hard when you first start, so some people find it easier to use the hand that's holding the wire and use that thumb to push against the wire strippers while the other hand stays firmly clamped down on its handles as it pulls away. You might find that easier to pull the insulation off. But those are wire strippers. Fairly simple to use. It's just a 3-step process when it comes down to it. And now we're going to talk about our last subject, which is wrenches and sockets and ratchets. Can you guess which is which? So this is a wrench, this is a ratchet, and the socket is just the attachment that's been put on the ratchet. So what wrenches and ratchets serve basically the same purpose of fastening nuts to bolts. They can come in a variety of sizes, as you can see here. Wrenches come in many different sizes, and the sockets, ratchets come in very different sizes as well for whatever corresponding nuts and bolts that you need to fasten. A wrench can come with 2 different ends. So the open end, which every wrench has, is this 2-pronged end. And then it might also have a box end, which is like this enclosed head that is able to grip the fastener from all sides, which gives it more leverage. So the benefit of the box end is that it actually offers a firmer grip, more leverage, and less slippage because it's got a grip from basically all sides. But you have to be able to actually slide it onto the nut or bolt from an open end. So you have to come onto it from on top. So that makes the box end actually difficult to use in tight spaces where there's little or no clearance. On the other hand, that's where the open end excels. So they're like two heads that kind of account for each other's flaws and benefits. On the other hand, while the ratchet is like a one-piece tool, or while the wrench is a one-piece tool, a ratchet requires a socket attachment to actually be useful. What's special about the ratchet design is that, unlike a wrench where you have to make a turn and then reposition it on the fastener head and then turn again, with the ratchet, you don't really have to readjust its position. You can just go back and forth because the ratchet can only actually turn in one direction. So there's no need to readjust. To change direction, you just have to flick the little switch here to go in the other direction. And each socket head is essentially like a boxed end of a wrench. It grips the nut or bolt's head on all sides, and it has to come onto the head from up top. And it also comes in a variety of sizes. Every socket, though, has one side with a hexagonal opening, so hexagon-shaped opening, and that is for the nut or bolt head. And then on the other hand, it has a square-shaped opening, which is used to lock onto this square protrusions on ratchet, which we call a drive. Ratchets can also come with different size drive, like we have a 1/4-inch drive, a 1/2 inch, a 3/8 inch, and even 3/4. We on FRC teams usually only use a 1/4 inch and 3/8 inch drives. But a socket needs to have the right sized hole as well to fit onto these different ratchets with these different drives. And to remove a socket, you just have to push on the back end of the ratchet's head and then pull the socket off. Oh, and in case if you forgot from the previous tools videos, it's clockwise to screw in and counterclockwise to screw out. Or you can use the more reliable right hand rule. But I talked about all of this in our previous tools videos, so if you want an update if you want to review that, or if you just didn't see it yet, check out that section on our previous tools workshop and the essentials of tools. And also in this picture, you can see that some of these sockets are longer than others. And the reason that we have these longer sockets is usually for reaching fasteners in like recessed cylinders, so at the very bottom of a long cylinder, or for those longer fasteners where a bolt might be far down at the end of or a nut might be far down at the end of a very long bolt, like they are in car exhaust clamps. So you can search it up if you want to know what I'm talking about. But in those cases, we need to use these longer sockets to actually reach them. And if you look really closely, some of these sockets actually have 12 points instead of 6 points. And so if you're wondering, why did we add 6 more points? Well, the benefit is that with 12 points, it's actually easier to grip onto the fastener's head because there's just more opportunities to lock into it. But the downside is that 12-point socket heads cause more stripping, which stripping, if you didn't remember from last video, is defined as shearing off material, usually on metal, and thus damaging a nut or bolt's head because you're getting it more rounded, and then the sides of the fasteners might not even be able to be gripped by a wrench or a socket anymore. And the reason stripping is worse for 12 points is just because there's more contact area, and the contact area is smaller. Sorry, the contact area is smaller, and it's closer to the points on the fastener when it's locking in. And also to note that all these tools come with imperial and also metric sets. So the imperial versions usually name their sizes as fractions like 5/16 or 3/8, which are the sizes of wrenches and sockets that we use most often on my FRC team. And for metric, they name their sizes as numbers like 2, 4, 6, 8, or 10. And make sure you don't mix up the imperial and the metric sets because sometimes a metric wrench might seem like it fits the head of an imperial size nut, but it's not going to be the right size. It's not going to be the perfect size, and it will end up stripping the head and damaging it. So make sure you're using the right size ratchet or socket or wrench for the right sized nut or bolt head. And with that, that concludes our very, very long presentation on intermediate tools. Thank you.